in more detail. So this is the CG for this piece of material, and I have a weight here also. So let's just assume that this is the CG of this airplane. Okay, and by that, what do we mean by that? It's the balance point. If I hold it back here, it will fall that way. If I hold it further up, it will fall that way. Okay, so the CG is like a teeter-totter, and it allows the plane to be flat with the earth where we're standing here. And that's the definition of the CG. Well, with an aircraft, the aircraft wing surface, which is the primary lifting surface here, will have a point somewhere in the center that has the most pressure, and we call that the average or the mean aerobatic center. So the mean aerobatic center must be found by using the geometry of this and finding the geometric center of the wing. That's the first step we need to do in order to find the CG of this airplane, which we do not know. When you get an ARF, someone has told you this information. But if you're building your plane from scratch, you have to determine it by some method. So this is the method that I'm using to determine. What we're going to do is we're going to take these dimensions here, this dimension, and we're going to put it up here. Take this dimension again and put it up here. So we've taken the short dimension and put it against the big dimension on both sides. Now, we're going to do the same thing with this dimension. We're going to take it down here, measure this, take it down here. Now, we have the means of finding the center by connecting the dots. Okay, so we've connected these dots from one side to the other, and we have found what's called the MAC, mean aerobatic center. Now let's draw in the rest of the aircraft. Let's say, we have an airplane here similar to the one we have, we'll say, like this. The other parts are not important right now. We're just talking about the nose here and the aft side, with its wings. So we're going to draw a line next in our process right across the center, and this is called the thrust line. So on the thrust line, we will now use the information with the MAC to begin to see where the CG goes. Here's how we do that. This is the process of that. Let's use another color. So the first thing we do is we scribe a line right through the MAC, going from the leading edge to the trailing edge. And we want this line, which is our green line, to be exactly parallel with the thrust line. The next step is we're going to measure this line, and I'll just do it by eyeball here, like it's in the same place of this line as the MAC. So we're going to find 1/4 of that dimension. So essentially we're going to divide this line we've scribed from the leading edge to the trailing edge using the MAC and using a parallel of the thrust line. Now the 25% here, dimension, 25%, has been found to be, through experiments and much flight theory and practice, to be a good number to use. Now what does this mean? Well, we're going to take this 25% distance here, and we are going to move it. If you'll allow me to draw a line straight up in here, and this is at 90 degrees. This dimension that we have just drawn and found to be 25% will be now moved up here, just arbitrarily. This represents our 25% line. So we've essentially taken this and just moved it up. We could have moved it anywhere here. What I'm trying to do is I'm trying to find 25% away from this line toward the front of the plane. Now what we're going to do is we're going to draw a new line right up here. And this is where we're going to put the CG of our aircraft. So that's how we find the CG. So let me go over it one more time here, just quickly. We draw the wing. We use this dimension at the top, this dimension at the top, and the big dimension at the bottom, and the big dimension at the bottom. That's how we got these 4 dots. We scribe a line. We look at the X. We draw a line that is parallel with the thrust line. We divide this line into 4 parts. We take one of the 4 parts, move it here with reference to this vertical MAC line, and then we find the CG.